हेलो फ्रेंड्स, इट्स इमानी। और आज की जो क्लास है थोड़ी स्पेशल है। इसमें हम लोग सिर्फ समरी की रीडिंग डालेंगे, वो भी स्ट्रक्चर ऑफ एटम की। तो चलिए शुरू करते हैं। देखिए, एटम्स आर द बिल्डिंग ब्लॉक्स ऑफ एलिमेंट. They are the smallest part of an element that chemically react. The first atomic theory, proposed by John Dalton in 1808, regarded atom as the ultimate invisible particle of matter. Towards the end of the 19th century, it was proved experimentally that atoms are divisible and consist of three fundamental particles: electron, proton, and neutron. The discovery of subatomic particles led to the proposal of various atomic models to explain the structure of atom. Thomson in 1898 proposed that an atom consists of uniform sphere of positively charged and with electrons embedded into it. This model, in which mass of the atom is considered to be evenly spread over the atom, was proved wrong by Rutherford's famous alpha particle scattering experiment in 1909. Rutherford concluded that atom is made of a tiny positively charged nucleus at the center, with electrons revolving around it in a circular orbit. Rutherford model, which resembles the solar system, was no doubt an improvement over Thomson's model, but it could not account for the stability of the atom. Why the electron does not fall into the nucleus. Rutherford, it was also silent about the electronic structure of atoms, about the distribution and relative energies of electrons around the nucleus. The difficulties of the Rutherford model was overcome by Niels Bohr in 1913 in his model of the hydrogen atom. Bohr postulated that electron moves around the nucleus in circular orbit. Only certain orbits can exist, and each orbit corresponds to the specific energy. Bohr calculated the energy of electron in various orbits, and for each orbit predicted the distance between the electron and nucleus. Bohr model, though offering a satisfactory model for explaining the spectra of the hydrogen atom, could not explain the spectra of multi-electron atoms. The reason for this was soon discovered. In Bohr model, an electron is regarded as a charged particle moving in a well-defined circular orbit about the nucleus. The wave character of the electron is ignored in Bohr theory, and orbit is a clearly defined path, and this path can completely be defined only if both the exact position and exact velocity of the electron at the same time are known. This is not possible according to the Heisenberg uncertainty principle. Bohr model of the hydrogen atom, therefore, not only ignores the uncertainty principle, dual behavior of electron, but also contradicts Heisenberg uncertainty principle. Erwin Schrödinger in 1926 proposed an equation called Schrödinger equation to describe the electron distribution in space and the allowed energy level in atoms. This equation incorporates de Broglie concept of wave-particle duality and is consistent with Heisenberg uncertainty principle. When Schrödinger equation is solved for the electron in a hydrogen atom, the solution gives the possible energy state and the electron can occupy, and the corresponding wave function psi, which is a fact, are the mathematical functions of the electron associated with each energy state. These quantized energy state and corresponding wave functions, which are characterized by a set of three quantum numbers: principal quantum number, azimuthal quantum number, and magnetic quantum number, arises as a natural consequence in the solution of a Schrödinger equation. The restriction of the values of these three quantum numbers also come naturally from this solution. The quantum mechanical model of the hydrogen atom successfully predict all aspects of the hydrogen atom spectrum, including some phenomena that could not be explained by the Bohr model. According to the quantum mechanical model of atom, the electron distribution of an atom containing a number of electrons is divided into shells. The shells in turn are thought to consist of one or more subshell, and subshell are assumed to be composed of one or more orbitals which the electron occupy, while the हाइड्रोजन एंड हाइड्रोजन लाइक सिस्टम जैसे कि हीलियम प्लस लिथियम 2 प्लस एट्सेट्रा ऑल द ऑर्बिट्स within a given shell have same energy. The energy of the orbit in a multi-electron atom depends upon the value of n and l. The lower value n plus l for an orbital, the lower is its energy. If two orbitals have same n plus l energy, then the orbital with lower value of n has lower energy. Okay, in an atom, many such orbitals are possible, and electrons are filled in those orbitals in order of increasing energy in accordance with Pauli exclusion principle, where no two electrons in an atom can have the same set of four quantum numbers, and Hund's rule of maximum multiplicity, in which pairing of electron in the orbital belonging to the same subshell does not take place until each orbital belonging to that subshell has got one electron each, is signedly occupied. This forms the basis of the electronic structure of atom. Thank you for listening. इसे आँख बंद करके आराम से लेट के सुनना और तुम्हारा स्ट्रक्चर ऑफ एटम का समरी कंप्लीट. थैंक यू फॉर लिसनिंग. बाय.